Hey everyone, and welcome to this session, this project level up session for the project European Cityverses in Uniting for Inclusiveness. We are in the month of May, and it's soon summertime, and today we have, as always, a super exciting topics to go through and to present. Let's start with this one. This slide. So a bit about the, yes, thank you. The project. So the project started with a common problem. The physical city is not accessible for all. And together we aim to create to lower threshold and make it possible for everyone to plan a visit ahead safely on their own device. Just want to remind everyone about, the actual core of the project. Let's see, it's a bit slow, my slide changing here. Yes, and then comes to our beautiful long name of the project. And European signifies where we operate, raising stakeholder awareness. Cityverse is developing this, it's about developing this new digital layer of urban life, connecting citizens, places, and services across AI and digital twins. Uniting is how we work using the methodology universal design, and inclusiveness is why we are doing this. We're setting a new standard for accessibility across Europe. At least our objective is to do so. We have a mission and vision, of course, in this project. Our vision is on the path to digital and inclusive Europe. And our mission is by this, listening to the families and the children, we are shaping Gothenburg into a more inclusive destination. And then uniting sectors, like we all are from the different sectors here in the consortium, we combine our expertise to make the city more inclusive and set a scalable model for other cities. And the project is very much about social innovation. We're finding new ways to solve complex challenges and to make the city accessible for all. We have 4 different objectives for the project, and we have them from the beginning, from the application beginning, of course. The first objective is the inclusive digital twin city design. Our second objective is the AI enhanced technical development and service integration. The third objective is strategic communication for project outreach. And then the fourth one, to develop a sustainable business model. So about these level up sessions. Now, these sessions are like training sessions that we are designed to strengthen the skills around our consortium and different sectors to ensure compliance. And then also, of course, about social innovation and also spark the collaboration across the project community. So most welcome to today's project level up session. And today the topic is advancing interoperability, MIMs and destination Earth. We had, as you can see on the right-hand side, we have had different topics more or less once a month since April last year. And all these sessions you can find on our team place, where you can find the recordings and the presentations. And of course, you do reach out to the presenters if you have any follow-up questions. And the next level up session is June 23 at 2 o'clock. We will soon set the topic also for that one. And you will have the invite update as usual. But then for today's session, this is about MIMs and destination Earth. And we have with us Mila Koeva from University of Twente in Netherlands, and Desislava Petrova-Antonova from Gate Institute in Bulgaria. These are our two presenters for today, and they will then present how the project will align with these MIMs, and also how we can contribute in any way and learn more about the destination Earth. So, and these sessions will be recorded, as I said earlier, and may be published externally as well. Also, we often do that. And meanwhile, we are presenting here. You are welcome to ask any questions in the chat, and we will take them on the following Q&A session in the end of the session. Okay, so maybe with that, we are ready to start and hand over to the first presentation for today. Desislava, or Desi, from Gate Institute. Your turn to enter the stage. Very much welcome. You have your slides and you will share them accordingly.
Thank you, Anna. I'm going to
soon
share my slides.
Yeah, let's see.
First, thank you for invitation to present Minimum Interoperable Mechanisms. And before this, I will put the context on urban digital twins, because the focus of CU project, one of the focuses is to apply local digital twin technology. So our understanding is that the urban digital twin should be reactive to the near real-time changes of the physical environment. And it has two main components. First, data, and then different actions. And these actions start with the collection of data about the physical environment, either using capturing, remote sensing technologies, also monitoring the dynamic of the city, such as urbanization, construction of new infrastructure, also traffic, energy consumption. And when we lack of data, of course, we rely on synthetic data generation. Then we use different connectivity protocols in order to fit the data in the virtual environment. And before starting with analysis and simulations, we need to prepare data in order to deliver high quality data sets that should be fit in different analytical models. So we perform a lot of activities related to data integration and linking, also enriching the data from various sources. And after that, analysis and simulations come where we perform descriptive and diagnostic analysis using different methods, starting with statistical methods, moving to machine learning, and other AI analytical models, performing predictive modeling and forecasting, and of course, using physics-based simulations. What is important is to communicate properly the results from analysis and simulations with the city stakeholders. So we can use here 3D visualizations and dashboard, applying immersive technologies like virtual reality and augmented reality, and even engaging the people with natural language interfaces like chatbots. And all these stages leads to production of new knowledge about the city, and this knowledge can be used for problem solving and decision making. And this decision making, of course, guide actions in the city, which potentially produce new data that need to be fit in the digital twin. So this is the concept of the digital twin, but on every stage of the implementation of the digital twin, we need different interoperable mechanisms. And I'm going to present now the essence of those MIMs. So what about the MIMs? They're minimal because they provide a cheap, reusable, and simple solution. And this solution can integrate ICT systems and data and support interoperability with different mechanisms, which can be tools, frameworks, scripts, best practices, and many others. So, where does the interoperability apply? You know that the city is a system of systems, so we can apply interoperability mechanisms to services, applications, different solutions in the city. And those components of the city comes from different domains. So suppose that you have air quality data that need to be integrated, for example, with traffic data in the city in order to estimate the impact of the traffic on the urban environment. And of course, you need here information about the urban infrastructure like roads, pedestrian network, etc. All these data sets come from different systems, and we usually cannot touch those systems, and then they produce data in different formats with different spatial and temporal resolution. What we can do here is to establish a minimal level but sufficient level of interoperability, applying minimal interoperability mechanisms. What is the value proposition of the MIMs? First, they provide common list of standards and technical specifications. Also, they serve as key enablers for the implementation of city solutions, and those enablers are available for all. And also provide a common marketplace of tools that can be combined in order to build digital twins. And we have different stakeholders of the MIMs, not only cities and communities, but also research organizations, businesses, innovation consortia, policymakers, and others. So the MIMs are divided in two main groups. The first group is called foundational MIMs, where we have MIM0 related to access of the data. This MIM provides solutions for collecting data from different sources and dealing with data silos in different sectors and even in one domain. Also, we have MIM2, which is responsible for representation of the data and aligning the data with the commonly established data models and standards. MIM1 is related to interlinking data. As I mentioned, the digital twins require data from various sources, and we need to connect those sources to produce high quality data sets. Of course, securing of the data is important, and this is relevant to MIM6. So we need to connect systems in a way that ensure secure transfer of the data. And MIM3 is responsible for data sharing, defining rules and policies for access and usage to data. Then we have application-based MIMs. MIM4 is related to mechanisms about the personal data and preserving data privacy and aligning the data, for example, with the GDPR and Data Governance Act. Then we have MIM7 related to geospatial data, defining different models, standards, tools for processing and analysis of different geospatial data sets. MIM5 is related to interoperable AI, and finally on top we have MIM8, which define the concept of local digital twin and also mechanisms that we need to build the local digital twins. Here you can see the MIM format. So each MIM is described with its objective. Then capabilities of the MIM are defined together with requirements for each capability. The requirements are connected with mechanisms and specifications, compliance rules, and finally we need interoperability guidance in order to show how particular MIM can be applied. So I will give a brief view of MIM8 local digital twins because currently I'm involved in the technical group responsible for that MIM. And the main objective of MIM8 is to ensure local urban digital twins to be able to communicate with other data ecosystems, can scale up, and can integrate new data sets, services, and components. So we have three, component building blocks here related to the dataset services and components. Then we have three main capabilities. The first capability states that LDTs are able to share data with other data ecosystems. The second capability states that the local digital twins are able to share services, and the third capability is related to sharing of components. And each capability is defined with different requirements. For the first capability, we have a requirement that data can be interlinked following MIM1, represented following MIM2, exchanged following MIM3, and secured following MIM6 across domains. And the second requirement is related to the ability of the local digital twins to work together. Then for the second capability, we have three main requirements. The first one is states that the services can be exchanged across silos and sectors. The second one is related to that the local digital twin can be applied to other data ecosystems with minimal integration effort. And finally, third requirement states that common services can serve multiple local digital twin installations. And for the third capability related to the components, we have similar requirements to those related to the services. So how to use MIMs? I will give you three examples. You can, for example, want to produce different technologies while maintaining the same capabilities and data, or you want to build and use interoperable solutions, or you work with a mechanism and want to access different mechanisms. In every case, you can rely on different MIMs presented here. So for the first case, we can have a situation when in your organization you can establish a new customer relationship management tool. And the idea here is that you need to transfer the data from legacy systems, for example, to the new system. And the problem could be with the access to the data and to ability to import historical data sets in the new system. And in this case, we can rely, for example, on MIM0 in order to solve the problems with the access to the data, to use MIM2 in order to represent data in a proper format in order to be imported in the new system following some established data models, And then you need a secure transfer of the data from between the systems. For the second scenario, suppose that a municipality needs some notification about air pollution in the city. And here you should connect two systems, one working in the local authority space and another, for example, at the National Environment Agency. In this case, the municipality, for example, should subscribe to notifications about air quality through APIs, but this is not a usual case. Sometimes air quality data is not accessible through APIs. It can be only accessed downloading CSV files. This is actually the situation with the Bulgarian Environment Agency. And this is a problem about access to real-time data for the environment. And in this case, we can rely again on three MIMs, the 01 for access of the data, and MIM2 in order to represent air quality data in a proper format, and MIM3 for exchange of the data. So, the third case, which leads me actually to the end of my presentation, is about startup company wanting to build a new mobility solution in the city. And here we want to connect to provide access for the startup company to different data sets that are produced by different parking providers. And here, an issue is the integration of data sets coming from different data providers. And the solution here is to have access to machine-readable format of the data, and some of the problems can be solved using MIM1 for linking of data coming from different providers. Again, you can follow different data models and data standards in order to put the data from different providers in a common format. And then you should rely on MIM3 for exchanging of data. Of course, we can put here also MIM related to data security in order to have secure transfer of the data among the participants. And this brings me to the end of my presentation. So thank you for your attention.
Great. Thank you very much, Desi, for this one. Let's hand over to, we take questions in the end. So Desi, anything in the chat, for anyone to ask any questions, and we pick that up. And hang on there, Desi, you will have some tricky questions in the end. So let's hand over to Mila Koeva, University of Twente. You also are to share your presentation, and we take a deep dive or jump up in the destination Earth.
Okay, good afternoon, everyone, or good morning, wherever you are in the world. Nice to meet you, nice to talk with you. First of all, thanks for inviting me to be part of this event. So my name is Mila Koeva. I work in the University of Twente. I'm Vice Dean Research, and also I work in the Urban Planning Department as an Associate Professor. Today I will talk about Destination Earth, or DestinE. Why am I talking about this? Because I am a national representative of the Digital Twin Group within Destination Earth. The slides that I will present, I kind of combine them from different resources because there is really an ocean of resources on the topic, so that somehow I can manage to deliver you the main message of what is this Destination Earth doing, what are these platforms providing to us. So in my presentation, I will focus on the digital twins of the Earth system and on why they matter for policy, research, cities, and climate adaptation as a whole. I will also explain the motivation, the European motivation, why we are investing in it. Then I will show you a little bit on the main components of the Destination Earth ecosystem. And then at the end, I will show you a little bit of the examples that have been provided in the web on this topic. Then, Destination Earth is in general a part
Mila?
of... Yeah?
I don't see you're sharing the slides. Sorry, but can you share your slides again?
I
am, but I can't see. Just wanted, because I didn't want to interrupt you on the
it's good
on
that
the intro, but it's
sorry, it's good.
Now we want to see the slides. Now we're curious.
This is the second
yes.
slide. You see
now I
now?
can see. Yes, I can see.
Okay.
Okay. So, thank you very much. Go ahead.
Yeah, thank you very much. So, Destination Earth in general is a part of a big European initiative. Europe wants to respond better to climate change, to natural hazards, to environmental pressure as a whole. And I guess you're all familiar with the European Green Deal, which provides political direction on becoming climate neutral and improving resilience as a whole. So Destination Earth supports this by building a digital capacity that can monitor, that can simulate and understand the Earth as a system. So when we speak about digital twins in this particular domain here, we should not think only about the technical models. We should think about the decision support capacity that Europe can do with these models. We should think about the ambitions that can help policymakers, researchers, public authorities to understand what is happening, what can happen in the future, and what choices we should make so that we prevent something of happening. So on this slide, I give you the main objective in a kind of direct way. Destination Earth is meant to be an interactive and reliable knowledge generation system. Important words here on this slide that I want to emphasize are interactive, reliable, and decision-making. So in practical terms, Destination Earth should help us, users, to monitor, to simulate the Earth system, to anticipate environmental disasters and social-economic consequences, and to test scenarios for more sustainable development. So I would like to explain it in a more simple way, so we can think of it like three main questions. First, what is happening now? Second, what could happen in the near or long future? And third, what should we do if we are the consequence of certain choice or some choice? So this is the logic behind the digital twin as a whole. Here on this slide, also it is kind of shown what do we mean by digital twin. It was also mentioned a little bit before me from Desi, but here it's good to mention that the definitions are aligned. The definitions and the concepts, no matter if it's looking from a Earth perspective or local perspective, they are aligned, and nowadays we all mean similar things. So digital twins on Earth system is again a digital representation that combines observations, models, simulations, predictions, and it requires a lot of computing power. But the key point is also interaction. It's not just a static visualization or static map. It is not also a database. It allows users to ask questions, to make some scenarios, to run scenarios, to compare them, and to predict some future things on our Earth. So, for example, what can happen if a heat wave becomes more intense? What can happen if flood occurs in a certain region? What can happen if we change an urban mobility or we change an urban infrastructure? So in that sense, digital twin can become useful when we can help people explore the consequences before we take any decisions. What is the system structure? There are three main components. The first is the core service platform. This is the entry point for the users. It provides access to tools, to services and applications. The second is the data lake. This provides access to large and kind of local or national databases, including data from European institutions or different programs. The third one is the so-called digital twin engine. This is where the modeling, the simulation, and the workflows are orchestrated. For me, the key message is the digital twin or destination Earth is not really a single model, and it's not a single website or a link. It is a system, if you want to call it an ecosystem, that can integrate data, that connects data, connects models, it doing computing and providing some services. On this slide, you can basically see the same. What is digital twin and how we can predict and do simulations for the future. On this slide, we can see that Destination Earth is a European initiative, and there are several actors, several key actors. European Commission provides the overall policy and the program direction, but there are three main implementing entities here. I believe many of you are familiar with them. For example, ESA, European Space Agency, or EUMETSAT, or ECMWF. They are all strongly connected to the digital twins or digital twinning and digital modeling. So, for example, ESA is strongly connected to the platform and the users that are working and doing some services on this platform. EUMETSAT is strongly connected to the data. It's a provider of Earth observation data. All of them are kind of connected with the member states, which are involved to a coordination group. For example, I started this presentation that I am a representative of the Netherlands. So I'm part of this member state working group on, in European Commission that has the different representatives. These working groups, of course, have some advisory structure, but also they produce roadmaps, regulations on how we work together, how the data can be interoperable and shared. Let me go to the next slide. Here, I would like to show the transition that Destination Earth is trying to make. In this current situation, Earth system models, and also they are, let's say, Earth system models and impact are kind of separated. The data can be different to access. The resolutions can be very different. Some can be coarse, some can be higher resolution, but the outputs many times are static. So with this digital twin approach, we are trying to bring all these elements together and to have a systematic update so that we have a dynamic output. How is this aimed to be done? It's aimed to be done by co-design with users, with people, with members from different organizations. So global aim that is uniting these people is to have impact. And mainly here is the impact of climate change, of extreme events, that is driving the ambition. Users need precise information that is not only scientifically advanced, but somehow accessible, it is timely, it is relevant, so that it can be used for a fair decision-making processes. Now let's look at the destination Earth materials. You can see that there are two digital twins that are being described. The first one is weather-induced extreme digital twin. This works on short time scales. For example, few days ahead, it can do some predictions. It can support questions related to storms, to floods, to renewable energy, air quality, or other extreme events. And the second one is climate change adaptation digital twin. This works on multi-decadal time series data. So the support question, or the main question that is important, is to observe the future climate conditions, to do different scenarios, to do some adaptation, to take some adaptation decisions, let's say. In simple words, these platforms or these digital twin systems can help us to prepare, to think about what can happen soon and how can we be a bit more prepared for what will happen. Yeah, in this slide, you also can see a little bit on the climate adaptation digital twin. It can also, as I said, make some predictions, projections, but also it can be it can go on an operational level. Normally, climate projection data can be produced in large cycles, and then it can be used as in a static output. But as I mentioned, we would like to go a bit into a dynamic world to see what would the current, let's say, climate bring in the future. How can we do some adaptation in planning, in infrastructure, if you want, agriculture, or in general, urban development. On this slide, the key word is co-design. So the central principle that Destination Earth system wants to promote is co-design. This means that they want to involve users from different variety of disciplines to be part of the platforms. So for example, ESA uses they have use case related to materials that are explaining and that are developing platform on that. For example, also there are test beds related to urban design, as I said, or some predictions related to climate and floods and so on. But the whole idea is that this has to be done together, co-designed. Here are actually some of the examples I managed to extract for you. They cover many areas of applications, like urban heat, like forestry, flood risk, air quality, or tackling different energy systems. The aim was not only to create some nice demonstrations, but the aim was to test the value of the Destination Earth as a platform, as a workflow for different scenarios, for different sectors, to involve representatives, as I said, from multiple domains, different sectors, different users, so that we all develop tools that are also practical and also easier to understand and to exploit later. This is some of the examples that I managed to find in the field. For example, this city nexus is a very relevant example for urban planning. It presented the digital simulation tool for urban planning that can support mobility again, air quality, some evidence-based decision making for cities. What is making this example interesting is the what-if logic. So a city can test scenarios such as low emission zones or road speed changes or green streets or active mobility scenarios. The digital twin can help to compare environmental and mobility indicators. In general, city can test planning ideas before them being implemented. Another example is this urban square, which is assessing the climate impact on urban areas and supports again some decision makers by showing assessment in dashboards. Again, here we have urban quality, urban heat, but also predictions in relations to rising of the sea level. The value here is the large scale, really large scale climate and environmental information that is integrated into the dashboard and into the platform. On the second phase that was demonstrated in Destination Earth, they were focusing more on pilot services. So creating or co-creating pilot services within a single platform, engaging multiple user groups. So that was the aim. In the example here, it includes storm search and ship routing, again, urban heat, but also agriculture and flood risk management. The important point is that these pilot services are closer to operational use, are not only experimental, but also they think a little bit beyond the experiment. They are kind of try to be made operational and have some a little bit more long-term predictive functionalities. This slide is very important for connecting Destination Earth with the local digital twins, the one that, for example, my colleague Desi was giving as example in the previous presentations. So how can we make the bridge from the global data sets covering Earth and local data sets covering cities or neighborhoods or even unique buildings? The key message here is again integration. How can we make the data integratable and the machine learning that is behind our demonstrations or predictions to be reliable? On this slide, you can see some materials that have been presented from EUMETSAT. This is, again, the link with AI. How can we use AI and machine learning in Destination Earth platforms? Can we use examples related to AI and cloud computing? You can see there are 3 use cases there. AI for clouds, enhancement of lower resolution products with AIDE, or the third one is Ether. So there are multiple use cases that are aiming for embedding AI and machine learning in those platforms. In this slide, the Destination Earth is broadening before the first digital twin output. It shows a little bit more examples. I don't plan to go through all of them, but the important message is that the system is trying to become a system for services, system provider for different services that can help a variety of users benefit from it. Here, I wanted also to bring your attention to the link between Destination Earth and ESA digital twin, because ESA, European Space Agency, is also building a digital twin that aims to bring the Earth observation products, scientific results, AI, machine learning algorithms, a little bit closer to the Earth. So we go to another scale. From the Earth scale, we go a little bit lower. So ESA can be the linking mechanism between Earth and local digital twin and national platforms. What opportunities we can have using such type of platforms? There are many opportunities. For example, access to climate data, in general access to information or system information, scenario testing, stronger link with European Commission, services for cities like energy, water, agriculture, disaster, or whatever. But we shouldn't forget that there are many challenges. The world is not so ideal. We need to think about users' need and the understandability of our results. Services should be easy enough to be used. We need to think about data integration between, as I mentioned, Earth and also local and national digital twins. We need to think also about things like privacy, ethics, data integrity, costs, and maybe many, many more questions. And we should think about these questions together. This was my presentation, and I would like to finish it with one clear message. The destination Earth is building or trying to build this European ecosystem where the Earth system data or digital twins or AI and high performance computing and of course users come together. They co-design all this together. So the goal is not only to produce more data, because we as researchers, we are very good in that, producing more data. The goal is not only to support some modeling, but the idea is to take all this together so that we support decisions in a fair manner, decisions in relation to urban planning, floods, air quality risks, or have some long-term predictions together in a kind of objective way. Yeah, I would be happy to discuss these topics together with you so that we make our final outputs more interoperable, more usable, and more understandable by all stakeholders. Thank you very much.
Okay, thank you so much, Mila, for this great presentation. Many applause coming in, perfect. So I leave the word to our question master or quiz master, Monica. Please go ahead. You have some great questions aligned to Desi and Mila.
Yes, thank you so much for your presentations. It was really good to have this really overview, and I will encourage all in the audience to write your questions in the chat if you have any questions for Desi and Mila. But the thing that like strikes me when I listen to this is it's about the scale. Like we're working with the Earth and we're working with Europe and we are working with local digital twins. And it's like we need to have like like a seamless line from the small easy peasy small bits up to the really overarching scale. So if you look at the CU project that are focusing on accessibility and a big focus on the people living in our cities and how they are able to to access the city or access the different cities in Europe and around the world. So the question is really for both of you, how can a project like CU focusing on the accessibility question, like where do it comes into these structures? How can we fit in those structures? So maybe we start with you, Desi. How can we manage to have CU put in all these MIMs?
Thank you for the question. My understanding is that the project can benefit from all MIMs because in general, CU project should produce inclusive digital twin relying on MIM8, which is related to local digital twins and development of interoperable digital twins. Of course, we need interoperability and on data level. So for accessibility, analysis of the city, for routing the people, finding how to say best places, best routes, we need data, and this data should be provided in interoperable format, which is related to MIM2 about data modeling. Of course, we need some analytical models to put AI on the table and developing some tools, even using generative AI and agentic AI to provide how to say interfaces in natural language that are more understandable for the people. We need interoperable AI because the outputs from the AI should be understandable also for the citizens, for all people living in the city. And of course, everything should happen in a secure, trusted environment that is related to the other MIM defined. So all these MIMs support the development of the digital twin, and will support also its CU project as a whole.
Yeah. Yes, that's exciting to see where we can really contribute or where we can work in this MIMS structure with the data that we have. So, but Mila, how do you see that accessibility for people could fit in Destination E?
Yeah, I was thinking on the same question. So in practical terms, I can answer that the city scale digital twins can just fit into the destination node as a local decision-making layer. I would put it as a layer. And destination, it can, the other way around, destination node can give us also some large-scale climate and extreme prognosis that we can use for our local digital twin. So the cities can answer their questions on neighborhood, street level, or so on. So I think this is a bi-directional data exchange, information exchange, if you want to call it, so that we both kind of benefit out of it. And if we put our final results in both platforms, then it would be the best.
Yes.
Yeah.
Yeah. So yeah, I think I get more and more questions, and I think it was very interesting to see also the Destination Earth and try to understand how we can contribute to those initiatives as well. So I really hope we can dig deeper into those questions in the end of this project. So just with a couple of minutes to go, I will leave back to Anna and see if she has any more questions. I don't see any questions in the chat, but of course you are very welcome to contact us after this session as well. So Anna, back to you.
Oh, thank you. Thank you very much, Monica, and special thank you to Mila Koeva and Desislava Petrova-Antonova.
Antonova, yeah.
Antonova. Oh, I'll work on it. Anyway, thank you very much for participating today. I think we are time's up, and we can definitely this was the first step of talking about these super interesting topics. And thank you for your sharing your knowledge today. And we, with that, say see you soon. Next Level Up session is on June 23. Here we go. June 23 will be a sort of a summer edition. We can reveal already, but more to come. So thank you very much for today. See you soon, everyone. Bye.
Thank you. Bye bye.